3, the composition of functions. Here are a few examples of some of the things that you'll be doing. For numbers 1 through 16, you're told that f of x is equal to 3x plus 1, g of x equals x squared minus 2x minus 6, and h of x equals x cubed. So these are things that you're given, and then you're asked to find. So for number 2, we'll do numbers, maybe 1 and 2, we'll do a few of them. So numbers 2, you're asked to find GOF of x. I don't really like this notation. We call this GOF. This O is really like a circle, so we kind of use a dot for times, and then we use a circle for something called compositions. Another way to write this would be G on the outside, G of f of x. And that's how I usually read it, G of f of x or GOF of x. And so what this means is we're going to plug x in the f. In this case, x is already found. But actually, number 2, there's a negative 2 in here instead of an x. So we're going to ask to find g of f of negative 2. So hopefully use pencil again. Then we're going to plug in negative 2 in for f of x. Okay, so if I do f of negative 2, I can do 3 times negative 2 plus 1, and that will equal negative 6 plus 1. So f of negative 2 is equal to negative 5. So now I can plug negative 5 in into my g function. That's what g of f of negative 2 means. Whatever I get out of f of negative 2, I'm going to replug that back in into g. So now off to the side, I can do g of negative 5 equals negative 5 squared. Make sure you put that in parentheses. Minus 2 times negative 5 minus 6, which will be 25 plus 10 minus 6, so 29. So we won't really actually write g of negative 5. We'll actually go back and write g of f of negative 2 equals 29. And that's our final answer. Okay, the other way that I would actually go about writing it is I would actually be plugging in this thing everywhere into this equation is how I write it out. You can do it either way. I'll just pick a different color for that one. So I would actually have gone about and wrote g of f of negative 2 equals, now everywhere I see an x squared inside my g of x, because this is what I'm going to start writing, this is my big picture, everywhere I see an x, I'm going to write 3x plus 1. Instead of x here, though, I'm writing negative 2. So I basically have 3x plus 1 squared from this guy, minus 2, and then I see an x, so I'm going to write my 3x plus 1. But instead of an x, I actually have negative 2 plus 1 minus 6. This actually might be more confusing when I'm actually using my numbers. When I have to do variables, though, this is how it's really, it's going to look this gross. Okay, so then I'm going to have 3 times negative 2 plus 1. That will be negative 6 plus 1. That will be negative 5 squared here. Minus 2 times negative 5 inside there again. Minus 6. So you can see how this line looks just like this line, since we've already figured that out. Okay, and then I know that I'm just going to get basically what this next line was, which was 25 plus 10 minus 6. And that got me the same thing, g of f of negative 2 equals 29. Okay, you might also be asked to find different things. You could be asked to find f of g, and that will look like f o g. For number 1, they actually ask you to find f of g of negative 1. Okay, so f was, I need to scroll up a little bit. There's all my problems. So f of g of negative 1, so I'm going to start writing f. Everywhere I see an x, I'm going to write g inside of it, or I can actually figure out what g of negative 1 is first. So I will do it how I write it, which is a little bit messier than what these two lines could be, these two things. So I would have 3 x squared minus 2x minus 6 plus 1. This is basically where my x was in the f. Now I'm going to go back and I'm going to erase all these x's and put in a negative 1. Negative 1. Negative 1. Okay, and that will give me 3 times 1 plus 1 minus 6 plus 1 at the end. That will be 3 times negative 4 plus 1, which is negative 12 plus 1, which is equal to negative 11. And I have done something wrong. Just a second. How about I forgot to multiply this by 2? So this is 1 plus 2 minus 6. So that will be 3. That will be negative 3. So this will be negative 9 plus 1. And that was negative 8. Okay, so if you were going to do it like these ones in black up here, it would look more like I'm going to find g of negative 1. So these are basically two different problems. So g of negative 1 would be negative 1 squared minus 2 times negative 1 minus 6. So g of negative 1 equals 1 plus 2 minus 6. So g of negative 1 equals negative 3. And then I'm going to plug in negative 3 in for my f of x. So now I have f of negative 3 equals 3 times negative 3 plus 1, which equals negative 9 plus 1, which equals negative 8. So this is what f of g, whoops, I missed a parentheses, f composed with g of x equals negative 8. Okay, it doesn't matter. It looks like you could really get it in about the same amount of lines. So just pick whichever way you like to use. So if you notice, actually, very rarely will you get these two numbers. So g of f and f of g. These aren't the same numbers that I plugged in, but they will very rarely get the same numbers out of them. So don't expect them to be the same thing. Okay, so a couple more examples. So we would have f of x equals the square root of x, and g of x equals x minus 3. The question asks you to find f of g and g of f. Okay, so f of g means that we're going to do f of g and we're going to plug in x. Okay, g of x means we're going to do g of f of x. Okay, so we're going to plug in the g of x function into f of x. So what that will look like will be the square root. Instead of writing x, we're going to write x minus 3. We're done with this function. The only other thing it asks us to do is the domain. So the domain of this thing, remember that square root functions pretty much look like this. So minus 3 will actually be to the right. So it will be all values, oops, this should be a closed bracket, 3 and greater, so 3 to positive infinity. You could also write just x is greater than or equal to 3. If you didn't actually know how to do this, you could go about and do x minus 3, and since it's a square root function, we just use this greater than or equal to 0 function. Equals not a function. Then I would add 3 to both sides, and I would get this guy right here. Okay, g of f of x, we're going to plug in this guy everywhere we see an x into this. So what we actually end up getting, so GOF is equal to the square root of x minus 3. Okay, we're going to be asked to find the domain of this as well. It doesn't really look like you're ever asked to find the range, but if we were to graph this guy, he would actually be down 3. That was a terrible square root function. That one was not any better. So this would be negative 3, where this would have been a positive 3 to the right, and this is a negative 3 down. Okay, so my domain in this case, I'm going to take everything underneath my square root sign, which is just x, so I would say x is greater than or equal to 0. There's nothing really to solve for. And I could also write it in interval notation, and I could do 0 to positive infinity. And that would be how I would do my domain of these guys. Okay, let's do another example. And in this case, it gives us that f of x is equal to 1 over x minus 2. And I'm just doing these examples in the book. I'm just working through them. So g of x is equal to 5 over x. Okay, fraction ones get pretty gross. In order to find the domain, remember when we get done, we'll plug in and see when these bottom pieces would equal 0. So first of all, to find f of g, that means, in other words, f of g of x. And I just write it both ways. Your book never really writes it both ways. I just like this notation more. Okay, so I'm going to plug g of x in. I'm going to plug this guy into my x everywhere I see an x over here. So now what that will look like is 1 over 5 over x minus 2. Okay, you would think this is where you're done. This is nowhere near done. I need to get a common denominator on the bottom first of all. So I will have 1 over. This 2 really needs an x on the bottom. So in order to get an x on the bottom, I have to multiply by an x on top and bottom. When I do that, I will then get 5 minus 2x over x. Still not done. I'm going to treat my 1 on top as 1 over 1 so that I can flip and multiply. I have a fraction divided by another fraction. So I will have 1 over 1 times x over 5 minus 2x. I'm flipping and multiplying. 1 times x is just x. 1 times 5 minus 2x is 5 minus 2x. Okay, if I actually had a number other than 1, remember that I have to actually multiply the 1 by everything inside those parentheses that I just made. Okay, then you're asked to find the domain. So we would write FOG first of all, and then we would say our domain. We're going to find out when the bottom piece equals 0. So 5 minus 2x equals 0. I'm going to subtract 5 from both sides. I'll have negative 2x equals negative 5. Divide by negative 2. And I will have x equals 5 halves. I would rather see an improper fraction than anything else. I think I've said that before. And those will both be pluses. Another way we could have wrote this one up here as well is we could have wrote f of 5 over x equals, and it equaled all these things then. Okay, so when we're going to be asked to find g of f, so this is a totally separate problem again now, So g of f, we could write that as g of f of x. We could also write that as g of what is f of x? F of x is 1 over x minus 2. So I'm plugging in 1 over x minus 2 everywhere I see an x for this one. So in this case, all of these things will equal 5 over 1 over x minus 2. Okay, I'm going to do the same thing I did with my 1 over here. I'm going to treat 5 as a fraction. So 5 over 1. Okay, and then I have really 5 over 1 divided by 1 over x minus 2. So then I'm flipping and multiplying. So I will have 5 over 1 times x minus 2 over 1. Since this has an addition sign in here, I need to make sure that I distribute this 5 throughout everything on this fraction. So I will get 5x minus, oh, I'm going to be sloppy here, minus 10. Okay, and I would write g of f, or gof, equals 5x minus 10. Since I don't have anything in the denominator, and I don't have any square roots, my domain is all real numbers. And since it's not an x squared, so since it's an odd function, it will cover everything and all those other fun things. But for both of these things, something that I also forgot is we have to go back and look at what the domain is for each of the original functions. So in this case, our domain is x cannot equal 2. In this case, x cannot equal 0. So I also have to go in and I have to add those restrictions on here. So I lied when I said it's all real numbers, but x cannot equal 5 halves, and x can also not equal 0 because 0 is what we plugged in, or g of x is what we plugged in. So I have to look at what I'm actually plugging in order to get that. Because if I were to plug in a 0 right here, I would have had something undefined. Okay, so don't forget about that. In this case, the thing that I'm plugging in is this guy. So when is this thing equal to 0 on the bottom? In that case, it's when x is equal to 2. So x cannot equal 2. So all real numbers except x cannot equal 2. And I forget about those things as well a lot of times. Okay. The next thing we have is called decomposing a function as a composition. So what you'll be given is something that says h of x is equal to 2x minus 3 to the 5th. And you're going to be asked to find f of x and g of x in a way that h of x equals f composed with g. Okay, so make sure you use an open circle, not a dot like I just did. Okay, they have your obvious solution and they give you a really non-obvious solution. And some of them are really hard to come up with. So we're just going to say f of x equals something and g of x equals something. Okay, so g of f we want to be the insidemost thing. The insidemost thing that I see is 2x minus 3. That's 3. Okay, so what could I have plugged this thing into to get 2x minus 3 to the 5th? It would have just been x to the 5th. And so those are some kind of weird things to get used to it. We're actually going backwards to find some things. There's no one correct answer for any of these. They give you the following example of this one that also would have worked. Equals x plus 7 to the 5th. Oops. And g of x equals 2x minus 10. And so f of 2x minus 10, which was g of x, will look like 2x. Oops. So f, so I will have something to the fifth. Instead of x, I'm going to write 2x minus 10 plus 7. Okay, negative 10 plus 7 will get me 2x minus 3 all to the fifth. I got the same thing. So these two could be a solution, these two could be a solution. There's pretty much a countless number of ways to do these ones. Okay, the next example they give you is h of x equals 1 over x plus 3. So the 3x, find f and g. So f of x and g of x. Okay, the one that they give you is they say f of x equals 1 over x cubed. Oops, this is kind of hard to see. So f of x is 1 over x cubed. G of x could be the stuff inside, so x plus 3. Okay, another way that I see that could be really obvious is f of x equals 1 over x, and g of x equals x plus 3 cubed. Okay, these, when I compose them, will get me the same thing. So don't get freaked out by these. There's a lot of different answers. Okay, I want you to do homework on page 185. And I want you to do numbers 3 through 48 by threes.